All right, we are live. This is Tom Nelson here, and I am very honored today to have Dr. Will Happer to talk about climate change. And do you want to kick things off by talking a little bit about yourself to get going?
Well, thanks, Tom.
Yeah.
I'm a physicist, and I spent a long time at Princeton. I'm a professor emeritus here in the physics department. This is my physics department office we're talking from.
Okay.
My specialty was atomic and nuclear physics, but I did a lot of work with lasers, especially in the atmosphere. So I knew a lot about lasers before I ever paid any, and about the climate and about the atmosphere before I paid any attention to climate science.
Okay.
Or to global warming. And I guess I got interested in it because one of my jobs in the early 90s was I was director of energy research at Department of Energy. And I had all the non-weapons research, which included climate, and but it was also high energy physics or material science. We even had a lot of work on the human genome. So it was, climate was a small part of it. But it was already clear then that it was not like any of the other parts of research that we were supporting, because even in 1991, 92, it was heavily politicized. And at the time, they were pushing for the ozone treaty in Montreal, which is sort of a pre-runner of the Paris Accord. So they were just practicing and sharpening their claws. And they didn't want anyone getting in the way with inconvenient questions about, you know, how good are the scientific facts behind this step we're taking, because there will be some costs. The costs weren't terribly significant for that. You know, it meant that many American companies made a lot more money, you know, because they could put patented refrigerants on the market and force people to buy them. And that's happening again now with the Kigali Amendment, you know, to get rid of refrigerants. And so yet more companies will make a lot of money, you know, at the expense of everybody else.
Yikes. Okay.
So anyway, I'm digressing.
That's okay.
My time at DOE alerted me that there was something funny about climate and environmental studies in many cases, that they weren't normal science. So I was quite vocal about that. I said, I don't know why you should have different standards in high energy physics or fusion or everybody else is supposed to be fairly rigorous in what they claim and be open to questions, which they were not. And so, of course, when the presidential election came, I was a political appointment. So Al Gore took a while to find me, but he did, and insisted I be fired. I remember Hazel O'Leary, who was the Secretary of Energy, a very elegant Black woman from Tidewater, Virginia, with whom I got along real well. We were both from the South, and for some reason we liked each other. But she called me into her office one day and said, well, Will, what have you done to Al Gore? I said, I haven't done anything to Al Gore. All I've done is insist on scientific standards. And she says, well, I got the message from the White House, I have to fire you. But, you know, we really like what you're doing. Say, I can make you a civil servant, you know, and instead of a political appointment, I can make that happen. I said, well, thanks, Hazel. You know, I came down here really as a duty, not because I was looking for a job. Hoping I can go back to Princeton, and I'll call them. And of course, they offered me a job back. I had to resign when I went to Washington. You know, I was a tenured professor, and I wasn't guaranteed to get a job back again, but I did. So that was my introduction to climate. And then, since I already knew a lot about the atmosphere and radiation transfer, I was amused by the incompetence of the, you know, many people in the climate area. You know, they really didn't understand what they were doing very well. And there were things that I knew a lot more than they did. And so anyway, this has become sort of my avocation in retirement. I hope I live long enough to see some progress made. It's been a hard slog because the opposition is so powerful and so many people benefit and are prospering from climate alarmism that it's very hard to stop.
Okay. All right. So it's often said that the reason that us deniers don't believe in the whole climate alarmism because we don't understand basic physics. Now, would you say that's your problem, that you don't understand basic physics? Or it's probably not.
I don't. No, I don't think so. Look, I understand physics of radiation transfer better than most people in the world.
Okay. Yeah, I think that's safe.
No, there might be there are a few that I would regard my peers, but none of them in the climate area.
Okay. Very interesting. Well, what do you think that the insiders believe? That's a question I had up here. Do you think a lot of the climate science insiders actually believe that the Earth is overheating or too hot right now? I'm curious your perspective on that.
It's hard for me to tell. The young people have been brainwashed, and so you have to cut them a little slack because all they've ever heard is this nonsense. And so I think some of the younger people sort of believe it, and they're very proud to be climate scientists. Everyone tells them they're saving the planet, and they go home for Thanksgiving dinner and all of their relatives say nice things about their about what they're doing. As they get older, I think many of them are having second thoughts, but they keep it to themselves because it's professional death to express any doubt about the party line.
Yeah. Do you think a lot of them went into climate science because they were full-on believers already? I get that sense that some of the young climate scientists were all in on alarmism before they even started to study in college. I don't know if that's true.
Yeah, I would say that that's certainly true of the people who are worried about how to respond. They tend to be not hard scientists. They really prefer to be sociologists, but they have to learn a little bit of science. And but they worry about all the terrible things that global warming is already doing. They tell you you can just look outside and see how terrible things are. I look outside. I've been looking outside for 80 years. I really don't see very much difference from 80 years ago. But they think they do. And so there's a thunderstorm and a tree falls down and they say, you see, didn't I tell you there's this climate change emergency coming on? Well, trees have been falling down for a long time. So I feel sorry for them in many ways. I think in hard sciences, it's much harder to recruit the best students because really good students can sense where there are really exciting and challenging problems to work on. And certainly climate is not one of them. That's my impression looking around at Princeton, that the best students, they'd rather be looking for dark matter, or, some fancy cure for cancer, something where there is a real problem there. It's important and there's no bullshit, right?
But how about figuring out how Earth's climate actually works? I don't know. Are there pockets of people that are actually trying to figure out what is causing the climate to change and they're not jumping to blame mankind for everything? I'm curious if, like, I know Willie Soon is a guy that one example, I think, that's looking at it. I don't know if there's a lot of people.
Well, Willie's convinced that the sun is the main driver, and he may be right. That it'll be a while before we know for sure. But the idea that there was a single control knob, CO2 concentrations that has determined Earth's climate, that's become a matter of religion. And people go back and they rewrite, encyclopedia articles. Look at an article about climate, from Encyclopedia Britannica, which is pretty good. 20
Yeah,
or
yeah.
30 years ago. It's not anything like what it is today, you know.
Mhm.
The worst of
Okay.
all is Wikipedia, you know, which is
Yes.
completely taken over by
Yes.
fanatics. And
Okay.
so it's a little bit like you know, the hero of 1984, what was his name, Winston Smith or something, but his job
Okay.
was to rewrite history. And so that's what's
Okay.
going on
Yeah.
with scientific history now. You know, everything has to conform to the idea that this demon molecule CO2,
Right.
you know, is about to destroy the earth.
Mhm.
I mean,
Yeah.
it's the craziest thing I ever heard because, you know, if you know anything about geological history, you realize CO2 levels have always fluctuated up and down by huge amounts.
Mhm.
What we're seeing now is trivial compared to what we've seen in the past.
Mhm.
And even day to day, you know, I have a little CO2 meter, and just out of curiosity, 1 week last summer, I monitored CO2 levels in my backyard for a
Okay.
week. You know,
Okay.
I got up at, you know, 3 or 4 in the morning so I could get a
Really?
4 hour late.
Nice.
And
Okay.
you know, on a calm day, you know, in my backyard, the CO2 levels by 2 or 3 in the afternoon about this time were typically down to 300 parts per million.
Really? Okay.
And, you know, by dawn the next day, again, if it was a calm day with not much wind to stir things up,
Mhm.
by dawn the next day, it was 500, you know. So it varied
Really?
by 200 parts per million, you know, between 2 o'clock and 6 o'clock. You know? And of
Okay.
course,
All
that's
right.
because of during the daytime, there I have a lot of maple trees, and it's a nice green city at Princeton. So
Yeah.
everything's sucking
Okay.
CO2 out of the air during the day. And if you don't have much wind, it depletes CO2 near ground level.
Okay.
And
Yeah.
then when the sun goes down, the respiration continues of everything, soil, microorganism, trees, you know, animals. And
Yeah.
so CO2 levels steadily go up. There's no photosynthesis at night. And so
Okay.
you get these huge swings, you know, 200 parts per million, just over 24 hours. And
Okay.
it's easy to, you can do that yourself. You don't have to get a scientist to do that for you.
Okay, that's very interesting to me because I think you have another quote in the past about CO2 levels in a growing cornfield when it's growing in the morning, that it might be 400 parts per million at the start of the morning, and it might be down to 200 as the corn is sucking in all the CO2 that it can. Is that, do I have that right?
Yeah.
Yeah.
I mean, it varies with
Yeah.
location and with seasons of the year. It doesn't fluctuate much in the winter because there's not much photosynthesis.
Okay.
But it's very this is well known to the agricultural community, you know, who've
Okay.
been measuring CO2 in cornfields and things like that for
Okay.
50 years. And
Mhm.
you know, if you put a monitor in a cornfield, just like my backyard, you know, by the middle of the
Yeah.
day, it's down
Okay.
to 200, 300 parts per million. And you
Okay.
the next dawn, it's up again. So this is a completely well-known phenomenon. I didn't discover it. I just wanted to see
Okay.
whether it worked in my backyard.
Okay.
It depends very much on wind, you
Okay.
know, because if it's a windy day, then this ground level air gets mixed up with air that's at 100 meters, 200 meters, which has not been affected by photosynthesis or respiration.
Okay.
So it's
Yeah.
closer to the sort of average 400 parts per million, 410, whatever it is now,
Okay.
that's in the upper atmosphere, where it's
Okay.
well mixed. But the ground level is not well mixed at all. It's not even close to being well mixed most of the time. So
Okay.
you get huge variations.
So this brings up all sorts of questions to me. Like, we have this story that CO2 was pegged at 280 parts per million for many thousands of years before we started to burn coal. Do you believe that, or was it fluctuating before that?
Well, you know, that's a
Yeah.
very controversial
Yeah.
topic. You know, I tend to believe the bubbles in the ice when
Okay.
you go to Antarctic and you core the ice, and you can tell when the ice was formed, and
Yeah.
you look at the gas in the bubbles and measure CO2.
Uh-huh.
And that does show huge fluctuations over hundreds of thousands of years. You know, CO2 levels
Mhm.
go way down during glacial periods when it's cold, and they come up again during interglacials like our
Yeah.
period now.
Okay.
But over the last 10,000 years, say, at least the Antarctic records, and to some extent Greenland also, don't show very much fluctuations. It's been around 280, 290 in the bubbles. There are people who say, well, there's a problem with that. There's something wrong. And, you know, I'm an experimentalist myself, so I listen carefully, but so far I've not heard what the problem is that could make me disbelieve it.
Just me as a layman, I'm wondering if that bubble has exactly the same chemical composition now as it did 800,000 years ago.
Well, that's part of the objections raised, but you know, you sort of know what the diffusion coefficients of CO2 are in the ice, and they're very slow. And it does seem to work over these long periods of time, you know, 100,000 years, you see these huge fluctuations of CO2. And by the way, they always follow fluctuations in temperature. You know, temperature goes up, you know, a few centuries later, CO2 goes up. You know, temperature goes down, the same thing. It takes a while for CO2 to respond. So it's clear that although it's correlated with temperature, the thing that is the cause is the temperature, not the CO2.
Yes. Okay. All right.
Gore used to say that you see this proves that CO2 is driving the temperature. In fact, it proved just the opposite. It proved temperature is driving the CO2.
Very interesting. So there's also these chemical measurements from maybe the 1800s where they used some chemical methods to measure CO2, and they had numbers maybe 450 or above. But they threw those out because they were way more than 280.
My own guess is it's this phenomenon I told you about my backyard, where you also see these huge fluctuations. But I don't know, you know, it's interesting that if you look at the measurements, the ones that are close to the canonical 280 are out away from civilization. For example, over the Baltic Sea. They typically would measure something close to 280. But if you're in a populated area, they got all sorts of measurements. And by the way, you know, this is outdoors. If you're indoors, a typical Princeton classroom, you know, the CO2 levels are 1,500 parts per million. You know, they're just enormous. You know, so if it was in a laboratory, God knows what they would have measured. I don't know. I mean, I've never thought it was very important because I think CO2 benefits the world.
Yes.
So, as far as I'm concerned, the more the better.
Interesting. Do you trust the Mauna Loa measurements, or are they throwing out the numbers that are too high or too low? Or I'm just curious. Isn't it a homogenized number that they're giving us? They're not giving us raw measurements, are they? That they're taking every day at Mauna Loa?
Homogenized number
for CO2 and Mauna Loa and the Keeling curve or whatever. When they give us that number every day.
Well, I've looked at the raw data. And I think they're doing a pretty careful job. The site is good because it's above the tropical inversion layer. So you're getting pretty well mixed CO2 from quite high up. There's a second observatory at lower altitudes where they have a lot more problems with just the I mentioned, where it fluctuates a lot from day to day. But the high altitude one is particularly good. And it's on a volcano, right? It's a shield volcano. So every now and then they get a cloud of CO2 from the volcano. And that stands out like a sore thumb. So they try to watch that carefully and make sure what they're seeing is from the atmosphere and not from the local perturbations.
All right.
I think they're doing a pretty good job. I mean, I knew Keeling a little bit, you know, he was at Scripps, and he was a very honest guy, you know, and he had a hard time because nobody would support his work, you know. They'd say, didn't you measure CO2 last year? Isn't that good enough? And he said, well, the whole point is, you know, to get a record. And but that was the argument in Washington. They kept cutting off his funding. And the only thing that kept him going was the director at Scripps was Bill Nierenberg. And year after year, Bill would come to the rescue and provide director's funds to keep that Keeling work going. And Bill is vilified, you know, as you know, a demon planet destroyer, you know, by you know, the likes of Orescus, you know, all these horrible people out there.
I didn't know that.
But he did a lot, you know, for that CO2 record. We owe much of that to Bill as well as to Keeling.
Is he vilified for not being a believer? I don't know why he's vilified. He's a
Well, because
yeah,
he was quite
yeah.
skeptical that
Oh,
there
he
was
was.
any problem with CO2,
Okay. All right. Interesting. I was going to ask you, what do you think is the optimum level of CO2 for life on Earth?
Well, I think it's probably around 1,500,
Yeah.
2,000.
Okay.
Greenhouses typically have at least 1,000 parts per million, and if they
Okay.
can afford it, they put in 1,500. You have to
Yeah.
pay for it, it's
Yeah.
not
Yeah.
cheap.
Okay. All right.
So it's a typical economic trade-off. And
Okay.
so you, as the owner of the greenhouse, you try to decide, okay, this makes my roses worth this much more, but it
Yeah.
costs me this much. And
Yes.
so you do
Okay.
that type of calculation.
Okay. All right. So you agree with Patrick Moore's idea that CO2 levels were going down for a long time before humans started burning fossil fuel, and by us doing
Well,
that,
you can
yeah,
see that pretty
yeah,
clearly from
yeah,
the studies of paleo
yeah,
CO2. I mean, like anything that involves proxies, there are uncertainties, but there are a lot of different proxies that give pretty much the same answer, that CO2 levels have been steadily decreasing for the last
right, yeah,
80 million years or so.
yeah,
For I don't know really what's causing it, but
yeah,
I think the data is pretty clear.
yeah,
Some of them are easy to understand. For example, you can look at stomata in
yes,
leaves, in fossil leaves, and
yeah,
when a leaf grows in air that has more CO2, it doesn't grow as many holes, and so by counting holes, you can get some idea.
mhm,
Another thing you can do is you can look at paleo soils. This is fossil soil
okay,
where CO2 is being, back at the time the soil was made, CO2 was being generated by metabolism, just like my backyard,
mhm,
and it was also being fixed. And CO2 that's been fixed in photosynthesis has a lot less carbon-13 in it. So
oh,
by
okay,
measuring the carbon-13 to carbon-12 ratio and trying to model how atmospheric CO2 would diffuse down and, photosynthetic stuff would diffuse up, you can estimate what the atmospheric levels were. So I would say that paleosol is probably the workhorse
okay,
thing. But there are enough different ones, and they're in enough agreement that I think it's absolutely clear that the CO2 levels in the past have been much higher than now.
okay, all right. Do you give humans the credit for raising the CO2 level from 280 to 420? Is that pretty much all us, or are there other factors, you think? I'm
Well,
curious.
that's the simplest
Yeah,
assumption. Many people
yeah,
don't agree. Many people think it's independent
yeah,
of humans. But my problem
yeah,
with that is if I look at the ice core records,
yeah,
it hasn't happened for many
yeah.
thousands of years.
Okay,
And
all right.
now here, all of a sudden, we're putting in twice as much every
Yeah,
year as is needed to
yeah.
explain the growth. So the problem has always been, where does the extra CO2 go?
Okay, all right.
Why isn't there enough to make there's too much going in to
Yeah.
be consistent with
So
what we observe.
I wanted to get your idea about this. Thomas Galstead had this idea that CO2 goes into the ocean and then it becomes calcium carbonate and falls to the bottom of the ocean.
Well, most
Yeah,
of I don't know the exact figure, but there's
yeah.
roughly 50 times as much CO2 equivalent in the ocean as in the atmosphere.
Okay.
And the reason for that is that the ocean is extremely alkaline. You
Okay.
can think of the ocean as sort of a weak solution of Drano, for clearing your
Okay. All
sink
right.
clog. It's like
Okay.
sodium hydroxide or a burnt lime.
Okay.
It's got a lot of OH minus in it, and so it converts the CO2 that comes into it into bicarbonate and carbonate ions, and so
Okay.
that pulls in CO2 from the atmosphere and
Okay.
makes the
Yeah.
ocean really supercharged with CO2. And
Yeah.
in fact, thank God for that, because if it weren't for the CO2, the ocean would be like Drano. Its
Oh.
pH would be around 13 or 14. I've forgotten the exact figure.
Oh.
But
Okay.
very much about the same as household ammonia. And most things
Really?
can't live in something that is caustic as that. Be
Okay.
like Mono Lake, say.
Okay. Okay. So this whole idea that our CO2 emissions are making the oceans uninhabitable for shellfish, et cetera. There's nothing to that, right?
No, of course,
Yeah.
it's
Yeah.
nonsense. It's not
Yeah.
true.
Yeah. Because I think they
Yeah.
say ocean acidification is like the evil twin of global warming. I think I've heard that phrase. It's
Well,
yeah.
you know, they were in desperate straits. A few years ago, we had this sort of 10-year hiatus. And so,
Yes.
you know, if we
Oh,
can't
yeah.
scare people with warming, we need something else. And so acidification was the next best thing.
Okay.
But, you know, the ocean pH fluctuates a lot from night and day, just like my backyard, you know. So
Okay.
that's for the same reason, because during the day you get photosynthesis. And so, you know, the microorganisms suck CO2 out of the water. And so since CO2 is acidic, the water gets more and more alkaline as the day
Okay.
goes on.
All
So
right.
in the morning, the pH might be 7.9. By the afternoon, it's 8.2, you know.
Okay. All right.
Again, it's just like the backyard experiment.
Yeah. And do I have
it does that day after day
Oh,
after day.
it does.
It's
Okay.
well known.
Okay. And do I have this right that the ocean would have to become way more acidic to be as acidic as pure water? Because pure water has a 7 pH, right?
Yeah,
So
pure
that's
water,
one way to think of it.
pure water in the atmosphere, as I recall, it's about 5.6.
5.6. Okay.
5.6, yeah.
Okay.
And so yeah, it's not possible really with
Yeah.
the amount of CO2 that you could burn to get the ocean.
Yeah.
You can't even get it below 7, you know. You
Yeah.
never get to 5.6. The problem is this enormous alkalinity, the natural alkalinity of the ocean, which few people understand. But
Yeah. Okay.
but it's I've forgotten the molarity, 2.3 or something, but it's very, very, very alkaline.
Okay. I did not know that. All right.
Yeah.
Okay. All right. So to finish,
you should bone up on it. It'll reassure you about the ocean.
I will. I got to do
good
that.
shape.
I definitely have to do that. Just to finish off the thought about Patrick Moore, though, that he was saying that CO2 levels were falling for a long, long time, and
Right.
humanity may have saved life on Earth because if it got too low, plants couldn't have grown, and because
Right.
we put more out there. Do you think there's some validity to that idea?
Oh yeah,
or-
and
yeah.
in fact, you know, during the last glacial maximum, there's a fair amount of evidence that plants were dying from not enough CO2.
Okay.
You know, they're quite respectable papers that have presented evidence for that.
Okay.
It's a particularly difficult problem at high altitude. So, you know, the high plains in North America, you know, the high plains in Asia, you know, you're up 6,000, 7,000 feet, and the air is already kind of thin. And now, you know, you take CO2 out of it.
Yes.
So it's a double whammy for plants. There's not as much CO2 to suck out of the air.
Yeah.
And then you're losing water like crazy too, you know. So the combination of water loss and not enough CO2 seems to have caused many plants to die off at high altitudes.
Yeah. So you did mention, I think, on the other podcast I was listening to, that the additional CO2 makes plants more efficient at handling water, right? And on the
That's
edges
right.
of deserts, they do better with more CO2.
That's
Another
right.
advantage.
You can already see desert shrinking, you know, that's very clear.
Right. Okay. And we're supposed to think they're expanding, but
You're
the
supposed
CO2
to think
we're
they're
supposed to think
expanding, but
that.
if you actually look at the data, it's the
Okay.
other, you know, they didn't get the sign right.
Okay. Okay. And there is significant an increase in global leaf area, right? Because of the additional CO2, probably.
Yeah.
Am I right? Okay. And what do you think is the addition in global crop yields at 420 versus 280? I've heard numbers like maybe 20 or 25%. Our crop yields are doing better. Yeah.
There was a recent paper by I've forgotten the authors, Taylor and I've forgotten the other, Sedler or something like that. But they're and I've forgotten the exact numbers, but they are saying of the order of 40% of the increase in wheat yield, you know, in the last 50 years has been due to more CO2. It's quite a serious paper.
Really? Wow. Okay.
I can
yeah.
send you the reference.
Yeah,
if you're
okay.
interested.
Yeah, I'll have to Google that. Very interesting. Have we covered CO2? Do we miss anything important about CO2 itself?
Well,
it's
you
very
know,
good. Yeah.
CO2 people should be grateful for, you know, it's a molecule of life, you know, thank God for CO2 in many, many ways. And it's completely harmless. And
yeah. Yeah. So the whole idea of carbon credits, carbon trading, that's all
it's
bonkers.
absurd.
I think.
It's absurd. Yeah.
Now, did you happen to see that there was a peer-reviewed paper that came out saying they wanted to have something like 200,000 teams of people cutting down trees and burying them full time? That's what they were going to do because the trees have carbon in them, and that's one way to sequester carbon into the ground. I think that was one of the most crazy things I've seen as a global warming solution.
I didn't see it, but
uh-huh.
I'm not surprised.
Oh,
There
okay.
are a lot of
Yeah.
crazy things being proposed here.
Yeah, or just carbon capture and storage. I don't know if what is the motivation for that. Some people say the big oil companies want to do that because they can use that carbon dioxide to get more oil out of the ground. I just saw an article about that. I don't know if you have any thoughts on that one.
Well, for tertiary oil recovery from, the best place to find oil is where you've already found it.
Yeah.
And
Okay.
usually there's quite a lot of oil left in a field when
Okay.
it's no longer economical with the
Okay.
technology you've got.
Yeah.
But you can invent new technology to get that out, a little bit like fracking. And
Okay. Yeah.
and one of the things they do use is CO2. So CO2 loosens up the oil and allows you to flush it out and get more to the
Okay.
surface.
Okay. All right.
So that
As it-
is a well-developed technology. It really works. And there used to be pipelines going into the oil producing areas in Texas and New Mexico that carried CO2 for
Oh, okay.
enhanced oil recovery.
Okay.
So that makes perfect sense. But that you're using it for a purpose, not because you're
Yeah.
trying to get rid of it.
Right.
You're perfectly happy if it comes bubbling back up to the surface again.
Okay. All right.
Yeah.
Let's see. One thing I have not asked is what is your best estimate for the climate sensitivity? If we double CO2 from here, how much warming do you think that we should get roughly?
I think it's probably around 1 degree, maybe
Okay.
a bit less than 1 degree.
Okay.
And I won't
Yeah.
bore you with going into all the details, but
Mhm.
that's sort of the first order estimate you would make. And it's surprising in science how often a first order estimate, it turns out to be the
Yeah.
best, when
Yes.
you start
Uh-huh.
improving on it,
Okay. Okay.
for some reason, it often gets worse. And that may not be entirely a mistake because, there's something called an asymptotic series. You've got a science background. You
Yeah.
probably
Yeah.
know about,
I think I
power
do. Yep.
series where
Mhm.
you take a first order term and then you add a second order correction and a third order
Yeah.
correction.
Uh-huh.
Well, asymptotic series are things where they do actually get better if you add correction, but only up to a certain order. So you might
Yeah.
be able to get a better answer up to the third or the fourth order.
Okay. Yeah.
Then the fifth order is much worse, and the
Oh.
sixth order is even worse.
Okay. Yeah,
And there are a
interesting.
lot of asymptotic series where only the
Yeah.
first order is the
Ah,
best. If you
okay.
take a second order, it's already worse.
Okay.
That was true of
Interesting.
quantum electrodynamics, for example, in physics.
Oh,
It
okay.
was
All right.
like an asymptotic series. So people got reasonable answers for the first
Mhm.
order, but second order, which ought to
Yeah.
work, didn't work. It gave infinite answers, that was
Okay.
clearly wrong.
Okay.
Nothing's infinite.
All
And
right.
so that was what really led to quantum electrodynamics. And the heroes there were Dick Feynman and
Oh, okay.
Julian Schwinger, but they were the ones who solved this problem that you had this diverging series. And so in
Okay.
climate now we have this diverging series, but it never occurs to people that, we've seen this before,
Okay.
and maybe you ought to rethink.
Okay. Do you happen to know if Feynman himself ever looked into the climate change thing or the CO2?
Many people have asked me.
Yeah.
I don't know. I didn't know. I was not close to him. My friend Freeman Dyson was very close to him and
Okay.
really admired him. And of course, Freeman was very, very skeptical about
Yes.
Feynman.
Yeah. Uh-huh.
And I would imagine that Feynman would have been his usual skeptical self. He questioned everything.
Okay.
And that's what you're supposed to do as a good scientist.
Yes. Absolutely. Yeah.
Especially your own work, you should question.
Yes.
And he's very insistent that, if you have nice theories, the real criterion for the theory is how well does it agree with observation and experiment.
Yeah. Yeah. His quotes are great. Yeah. Mhm. Yeah. Mhm.
And certainly the climate community has not done that. They don't agree with observation and experiment. And so what they do is they go and change the previous observation.
Right. Yeah.
Winston Smith from 1984 again, right?
Yeah.
Changing the past.
So are you following the work at all of Tony Heller when he's actually looking at in great
Yes,
detail about changing the past?
you know, I'm busy, so I don't look at everything he does, but I think he's making some very good points. And
I think he is. Yeah. All right. I was going to ask you also, if we burned all of the known fossil fuel reserves, any idea how much global warming, if we were really trying to emit as much CO2 as we could, how much warmer could we make the Earth?
Well, it's hard to know how much fossil fuels are economically available. There's a lot more than we used to think. But I don't think there's enough to get to 1600, which I think would be would be quadrupling, which I think would be about right, for maximum greenness of the Earth. And very little change in climate. People really don't realize how ineffective greenhouse gases, especially CO2, how ineffective it is. So, for example, if you double CO2 from present value, which is a little more than 400 to 800, that only changes the radiation to space by 1%. So it's a tiny amount. And you know, as from your background in science, that things radiate as the fourth power of the temperature, to zeroth order, first order. And so that means that the temperature only has to change by 1/4%. To deal with a 1% change in flux, because the flux changes so rapidly. Temperature of the fourth power. So if you use that type of argument, you would say that, well, doubling CO2, which is about the maximum you can get out of fossil fuels, I think, would give about 1 degree warming, which would be no problem. Most of that would be in, high latitudes, closer to the poles. It would be hardly changed in the tropics, and a little bit warm in temperate zones. But there's absolutely everything about it is good, not bad.
And constantly we're hearing about oh no, we're going to hit the tipping point, but they're not real, are they? I don't know of any evidence.
No geological evidence that there's ever been a tipping point.
That's, as a layman again, I think there can't be, because the Earth has been way warmer and we never hit a point where we became an uninhabitable fireball. So
that's right. It's sort of the anthropomorphic principle in disguise. If there really were tipping points, since the Earth isn't very stable, we would have passed them long ago and become extinct. Right?
All right.
So it's pretty clear they're not there.
All right.
But the gullible, there are always gullible people who will buy this stuff. And
so what do you think is happening with, I don't know, the Royal Academy or all these different organizations that put out a warmist statement? It seems to me like a small group of them have been captured somehow. But if you actually were to survey all of them,
they've been hijacked by fanatics, and I'm not quite sure how this happens. One thing is they tend to get taken over by people who've stopped doing creative science. So if you were a wunderkind and are having trouble being a wunder adult, because you can't think of anything very creative to do, you can always become president of a learned society.
All right.
And then you can pontificate, and people will listen in awe. And so that's part of the problem, is that you don't get the best people. Dick Feynman would never have been president of the National Academy of Sciences. He would have quit in disgust after the first week.
Interesting. So what I'm never seeing on any of these statements is where they surveyed the rank and file, everybody, and said, do you believe there's a climate crisis right now? I'd love to see that. Take any professional society you want and survey 10,000 people.
They're afraid to do that, because they know they will get a very substantial number of returns of people say, I don't believe this nonsense. They know that perfectly well. And so they have done surveys, and they know that's the answer they get.
They do.
So they don't release them. So they keep them secret.
Okay. Do you think there's room for maybe some third-party people to try to do that on the side somehow and publish the results? I'd love to see those results somehow. I think the
Well,
public
it's
should
an
know. Yeah.
interesting question. I don't know whether people would pay attention to a third party, but anyway, look,
Yeah.
it does touch on the important thing is that you don't define good science, true science by voting.
Yes.
So even even if 100% believe that it's
Yes.
nonsense or 100% believes it's true, it doesn't matter. It's not relevant. The question is, how well do theory and experiment match
Yes.
up?
Yeah.
It's this famous 100 authors against Einstein.
Yes.
That,
Yeah.
was written in the early 1930s when the Nazis were coming to power, and so Einstein's views on relativity were very unpopular among some in Germany, although he was German himself, and many supported him. Max Planck was a strong supporter.
Okay. Mm-hmm.
But they put together this crazy book, article after article about why relativity was wrong. It was mostly focused on special relativity, but I think there were a few on general relativity. But when Einstein was informed about this, he says, well, why do they need 100? One good paper pointing out a flaw is all they need.
That's great. I love that.
Yeah. So that's the way science is supposed to be, that, there really is an objective truth out there. It's not the term, you don't vote on the law of gravity, it's something that you observe.
Right. Right.
Whoever made the law of gravity, it wasn't the US Congress. Right?
So how do you see this playing out? Like, how much longer can this insanity last even inside the scientific world and the groupthink? Do you think it has to break down, doesn't it, at some point in the near future, or can this hang out for another decade?
Well, I think the most hopeful thing, and I say this with some sadness, is that it looks like that maybe the chickens are coming home to roost in Western Europe.
Mm-hmm.
They're facing serious energy problems because of the climate fanaticism that's run the show there for the last 20 years.
Mm-hmm. Yeah.
And so if they have a particularly bad winter, and if things go badly in Ukraine, there could be very serious consequences. There could be social unrest. People might be held account. They should be held account.
They should be.
For what they've done.
Mm-hmm. Okay.
So I think the thing that is going to end this will be some disastrous consequence, that there's no longer any question that these guys are crazy. It sort of half happened in Sri Lanka, where Sri Lanka was governed by several years by truly woke politicians, and they went all to organic farming, and and of course, people started starving to death, right? And massive famines, and so what's needed is something like Sri Lanka, but on a larger scale, and some large political unit. Germany, United Kingdom, California, maybe.
California,
on that path.
I mean, what do you think is going to happen in California with this whole idea we're going to get rid of all the gas-powered cars and try to charge everything, use electric cars instead, even though they can't charge their current electric cars? Sometimes, I don't know.
Well, I think it will collapse. I don't know how long it will take. The thing that makes it convenient for the present politicians is it's something that's going to happen long after they're out of office, and hopefully drawing a fat retirement package.
Okay.
So I think when that happens, these people should be put on trial, and their retirement.
I mean, it's all fun and games for now. When exactly. Okay. All right. I wanted to ask you about just there's all of this propaganda about the weather's getting worse, and if we get another degree of warming, the weather's going to get terrible. Have you looked at that in great detail? I don't believe a single bit of that, but do you have any feedback on that?
Of course, it's complete nonsense. There's not a single measure of weather that shows anything alarming. my friend Stephen Koonin wrote this nice book on Unsettled, I think was the title.
Yes, yep.
But it was focused on what's really happening to the weather. And so there are chapters there about hurricanes, tornadoes, droughts.
Yes.
And it's very well documented, and nothing's happening, If anything, it's getting a little better in many places. And
okay. All right. Good. Yeah, I'm not worried about it.
yeah.
Are you a fan of Alex Epstein's work by any chance about fossil fuels?
Yes.
Yeah.
I think the more people stand up and make the case that this is immoral, which is a key part of his message, the better. Yeah.
Okay. Do you have advice for us skeptics as to just what arguments you think are the best ones to use?
Well, I think it's very hard because you're surrounded by religious fanatics, and many of them are your own family, and people you don't want to offend. And and they're basically decent people, but they've been badly misled, and it's like questioning someone's religion.
Yeah.
Is it religion?
Yes, it is. Yeah.
So I don't think there's a silver bullet argument that will work for everyone. And in fact, many people, those who are convinced for religious reasons, you can't change their mind. They just will not change their mind.
Yeah.
And there are not many people in the middle whose minds can be changed. Most have already taken a stand one side or the other. So I think the most effective thing we already talked about is disastrous consequences of the policies to address this made up threat, this threat that doesn't exist. And but many people don't realize how corrupt this fundamentally is. Utilities, they love global warming. They love renewables because they can jack up the prices. So they become very, very profitable. If you've got a fully depreciated coal plant that's reliably supplying your customer base and not providing you a very good return, you can get rid of that, and put in windmills, and then you can charge much more. And so the profit line goes way, way up. So there's this perverse incentive, to get rid of dispatchable power, reliable power, to help the bottom line, the profit line, help your investors.
Okay. Yeah, I've heard some talk about it's good for some companies to get rid of coal power because then natural gas is maybe one of the only games in town where they don't have that competition from coal. I don't know if that's
well, natural gas. The nice thing about natural gas is that it's so cheap to build a natural gas plant. It's sort of the lowest cost capital investment you can make. It's a lot less expensive than coal. And it's much less expensive than nuclear.
Yes.
And I'm all for that. It's amazingly efficient too. With these combined cycle plants, you're getting well over 50% conversion of heat into electrical energy, which is phenomenal. In a coal plant, it used to be, 35%. Maybe it was a good plant, and now with ultra supercritical, it's up into the 40s. May still go a little higher.
Okay. All right.
But the champions are the combined cycle gas plants. They're amazing.
Okay. All right. Do you have thoughts on nuclear power? Whether you're a fan of that?
Well, I think it's a good way to make electricity. And it's too bad that it's had such hard times all over the world, at least the Western world. It doesn't seem to be bothering the Chinese, who are building nuclear plants as fast as they can.
Okay.
And I think it makes good sense for China. They've got a lot of people. They would like, reliable, affordable power. And you can get that from nuclear, but you certainly can't get it from windmills and solar panels.
Right.
They're happy to they're happy to sell that stuff to us.
I'm hearing it.
As long as the price is right.
So do you have thoughts on battery technology, whether we ever will see a huge, like a quantum leap, or are we kind of running up into some roadblocks where we can't get much more energy density?
No, look, people keep talking about Moore's law for battery. It's absurd because battery technology is the first batteries were already working pretty well by 1800. Michael Faraday used quite good batteries, and zinc, copper batteries, they worked fine. Put out a lot of current. And nowadays, we've gone over to lithium, and it really is an amazing battery. It's small and light, and you can store a lot of energy, but it's quite dangerous. And there's not going to be a quantum change in lithium batteries. So it's a technology, and it has a fundamental problem. It's wet chemistry. And so every time you discharge a battery, you have to regrow crystals when you recharge it again. And then you can't control the growth of crystals. And so gradually you start getting strange things happening that you can't really control, dendritic growth here and there. So all batteries essentially go bad. They eventually go bad.
All right.
And you just can't do anything about that. And so there has to be an infrastructure to handle all these bad batteries and recycle the lithium and the cobalt and all the other valuable things in them. And you could do that, but we ought to do it if it's cost effective, not because it's a mandate from fanatics.
Absolutely. Yeah. Okay. Do you have thoughts on maybe like hundreds of years down the road, if we're out of fossil fuels, and if people tried to drive a private vehicle across the country, how would they power their car? We have nuclear plants maybe producing.
They'll power it on synthetic diesel or synthetic gasoline, because in a few hundred years, you got to hope that we will have figured out how to do fission and fusion efficiently. So we'll have a lot of electrical power. And if you have enough cheap electrical power, there's no problem making synthetic hydrocarbon fuels. You make them out of limestone and water. And it'll be a long time before someone invents a better motor than the gasoline or diesel engine. They really are amazing. But they do need fuel. And so I think in a few hundred years, we'll still be using them, but we'll be using synthetic hydrocarbons.
Okay, very interesting. So thank you very much, Dr. Will Happer. I've super enjoyed this, and I hope to have you back on again sometime. Thank you.
Thanks very much, Tom. Keep up the good work.
Thank you very much. Talk to you next time. Bye.
Okay, bye-bye.